The good news is that I finally managed to make a sample. It has nanorods on it, and these are the nanorods. With any luck, all of the dust should only be like on one finger at a time, which doesn't affect anything. So hopefully I can actually do some measurements in the next 2 weeks. I have nanorods. So now attaching my sample to the stage inside the platform, inside the ultra-high vacuum chamber, which is where I'll be doing my experiments. If anything electrical happens to the chamber, it's going to happen to your sample. You don't want that. It would sort of screw up the test. So sapphire is actually pretty unusual in that it's electrically an insulator, but it's thermally conductive, which is exactly what we want here. So the copper, thermally conductive, also electrically conductive. Sapphire transmits the heat from the copper to the sample, blocks any electrical signals. Then your sample sits on top of on top of the sapphire. The problem is you can't just stick the wires on and leave everything the way it is, because the actual setup when you get inside the ultra-high vacuum chamber is that you turn the copper stage on its side, so the sapphire plate is vertical, and if you just put the sample on the plate and then turned it, it would obviously fall off. There are a few different requirements for the material that you use to basically temporarily glue your sample to the sapphire. One, it's got to be thermally conductive, and it's got to fill the gaps between the sample and the sapphire so that it will continue to transmit heat from the copper to the sapphire to the glue to your sample. It's got to stick to both silicon, which is the underside of the substrate, and sapphire, so that it actually functions as glue. And it's got to be something that you can remove when you're done without breaking the sample or damaging the sapphire or making a complete mess of everything. So what I've been doing this week, very briefly, is trying to find materials that are good for that. The ones I've been testing today are gallium. So gallium melts, actually you can melt in your hands. It melts at slightly under 30 degrees Celsius. It's slightly toxic, but that's what gloves are for. And I tried using that. The problem is that the melting point is so close to room temperature that it takes forever to re-solidify, so we never really figured out if it actually sticks to sapphire or silicon because it was still molten like hours later. I'm still in the testing phases.